Hi, we will discuss descriptive statistics from class 11 today. This statistics we have studied in class 9-10. We know that it deals with some kind of information which is collected in numbers, data. For everything and anything, this data is very important. We have got in Google, if you type about any data, the people, those who live in this particular state, in particular district, how many children are studying in class 10 in India, for everything there is an answer. How did they get? They must have, there was like a census, somebody must have collected all this, which we call usually raw data or primary data. With the help of that only, we will come to conclusion. For example, if you ask, what is the life expectancy of a man in India? We may have an answer. That may be 65 years or 70 years. A single number we get for millions of people live in this country. Now, what is the method they adopt? You must be remembering that mean, arithmetic mean or average of the of a group of people or a sample of people, and then they get a single number. Like this middle number we can choose. When you arrange in ascending order, descending order, you take the middle number is median, or the more times what occurs you will say mode. This type of measurement is called a measure of central tendency, which you already studied. Then what is new in class 11 is measures of dispersion. What does measures of dispersion discuss? It checks the authenticity of the mean, median, mode that you have found. See, I say that for example in a class we conducted a test and somebody got 10 out of 100, somebody got 90 out of 100. You see, when you take the average, it is nowhere near 100 or 90. You will get somewhere in between, somewhere 50 or something as the average. But that 50 is so away from what? Your 90 marks and so away from your 10 marks also. So our answer, it doesn't do justice with these numbers. So how far it is away from other numbers, that we check. That is what we call as the measures of dispersion. How much it is dispersed, how far the data is. Are the data are so close? See, when Indian cricket team bats, the opener suppose get 130 runs, the second person is getting 0 runs, third person is getting 5 runs, fifth person is getting maybe you say 75 runs. This is not a consistent. You will say the players are not consistent. You didn't like the kind of batting. Whereas Australia, when they bat, then you will say that the runs are so close. Most of them are making around 40, 50. Then you say all the players are consistent. All will contribute. That kind of a data you may like. So that data appears to be a little more good, better. So what I wanted to say is, this dispersion discuss about how far the data is scattered. So for that we have got a method, that is mean deviation. This mean deviation can be calculated with the help of mean or median. First you will find a mean and we will subtract and check from each of the observation how far this mean is away. Then its average is taken. I'll explain the formulas in the next video, but we will write sigma xi minus x bar divided by n. So all the data we will subtract from the given data how far away this mean is. So that is one method. I just want you to remember this name alone, mean deviation. That if you can use the median also. Each data is how far away from median also. So they will mention in the question about what you should find the mean deviation. That is the first thing. Then another type of measure is variance. With the help of mean, again you will find xi minus x bar, the whole square. You have to square it and divide by the total number of observations, n. That is variance. And this variance, if you find the square root of it, then it is called a standard deviation. So standard deviation is the square root of variance, or variance is the square of standard deviation. And then we have skewness. Skewness mainly deals with the we know when a distribution is made, a frequency distribution is made in a pictorial representation, you may get a curve. That curve, if it is a symmetric curve means it will be like this, where this with respect to a line, both sides it will be symmetrical. Here in this case, we will say mean equal to median equal to mode. Everything will come equal. All this should be equal. If they are equal, then it's a very good data. Mean, median, mode, everything will be equal. Now, it is not necessary that all distributions should stay like this. If it is not staying like this, how much it is deviated, that we will measure. That kind of measure, how can we measure? That method is what we mainly study in class 11 skewness. One of the important area, or so much of work is done in this skewness itself. We can find it in different. Carl Pearson method is there, like mean minus mode divided by standard deviation, or 3 times mean minus median divided by standard deviation. Then Bowley's coefficient method is there, using quartiles Q1, Q2, Q3, like Q1 plus Q3 minus 2Q2 divided by Q3 minus Q1. We will write the formula. I will explain it, how to go about that. Then something called moments. For that we should understand what you mean by moment. That also sigma xi minus x bar, the whole to the power r divided by n. We have a formula. Then moment 1 is there, moment 2 is there, moment 3. We represent it by mu. Mu1, mu2, mu3. That we will find out. That will be used for further understanding about the skewness. So I said, so skewness can be calculated with SKP, that is Carl Pearson coefficient method, that is what I said, mean minus mode divided by standard deviation. SKB, that is using quartiles. Then moment coefficient, beta 1 method. Beta 1 is mu3 square by mu2 cube. I will write the formula. Don't worry about that. I will classify those ones. So that method also, looking at the beta 1, we will check whether it is negatively skewed or positively skewed. It's like that we will be able to understand the skewness of it. Then the other thing that you should discuss here is kurtosis. Kurtosis about, we will discuss about how relatively how much peak the curve is, whether the curve is this much peak or this peak. So we will say that if it is equal to 3, if that we will represent by beta 2. Beta 2 is moment. Using moments only we will calculate. Mu 4 divided by mu 2 square. Mu 4 like this, divided by mu 2 square. This we calculate. And beta 1 I said mu 3 square divided by mu 2 cube. This all I will write in detail, the formula. You see the second part of it. So using that you will say mesokurtic. If it is beta 2 is equal to 3 means mesokurtic. If it is less than 3 we will say platykurtic. Or if it is more than 3 leptokurtic. Likewise we will be able to classify and understand it. This is what one area of that skewness. Then we have got correlation method. When we come to correlation, all these data we were discussing about for a univariate data, a single data about height of the children. That is where we speak about all this. We have only one data. When we have two data, height of two different sects of people of section A and section B, you make a comparison and study. That is when we will use their correlation. Correlation also, we have correlation method is there. 3 methods mainly we discuss here. One is the covariance. We have got again formula for finding that one. Sigma xi minus x bar into y minus y bar divided by n. Likewise we will make a formula and with the help of that only we evaluate it. We have got shortcut formulas also there. Then using Carl Pearson method also we have got we can find the correlation and Spearman's rank correlation. These are the areas we discuss in descriptive statistics. So through this video, what I intend is just to be familiar with these names. So if you don't connect all the, okay, I didn't tell one more thing, that is the measure of position. Measure of position, we'll study about a percentile rank also. What is percentile rank if you ask me? We know percentage of a student, we can think about. If I say that I got a 90%, you know only my position. You do not know the rest of the people or rest of the students in my classroom. I got a 95%. What about the rest of them? Or what is my rank in that? If I can discuss it through a percentage method, that is what percentile rank. For example, when I say my percentile rank is 90%, means 90% of the students are below me. So I am that much ahead of them. This is especially used in entrance type of examination, JEE exam results and all. Percentile rank, when you understand, you will know whether you get. Even if I get a 50% only, but my percentile rank may be 90. Percentile rank may be 90. Then it will be looking good. So the 90% of the people are below me. So that is what percentile rank, the measure of position. Then the correlation is actually measure of association. These terminologies, if you remember, that's good, but basically you should know in class 11, what you should know is which are the measures of dispersion, that is mean deviation. It's an important question. Variance, standard deviation, this we will use next year also. Inferential statistics also, these terminologies will come. Then skewness, kurtosis and measure of position, percentile rank in day-to-day life we may use or we listen to that. Then measure of association, correlation. These are some of the new terminology which you comes in the, and some beta 1, beta 2, mu 1, mu 2, mu 3, mu 4, etc. This and all how to find it. So next video I will classify, I will neatly write all the formula and explain how we can go about with each question, for example, standard deviation. How many different formulas we can have, whether the shortcut formula or the standard formula, what is the easy way to reach the answer, that we will discuss one by one. Okay, so watch that also. Thank you.